Hello children, in this video we are going to consider the general form of the quadratic equation ax squared plus bx plus c is equal to 0, and we are going to find the roots of this equation. This is the general form. We've just instead of the numerical coefficients which we normally write in our many examples, here we have taken a real number. A represents any real number. This is also a variable, but it represents any real number. A and B is the coefficient of x, again represents a real number, and C is the constant term. So now we are going to find the roots by using the same completing the square method, right? So let's proceed. We have to compare this with the square of any polynomial, p squared plus 2pq plus q squared. So this p plus q the whole square looks like this, isn't it? P squared plus 2pq plus q squared. So comparing these two, we see that of course there is a square term here, but the coefficient is a, which has to be eliminated for the purposes of comparing with this p squared plus 2pq plus q squared. So it's very easy. Just divide every term by a. Divide every term of the equation by a, and also the right hand side by the real number a. The only condition is a should not be equal to 0. Of course, if it is equal to 0, it is not even a quadratic, isn't it? The x squared term will vanish. So you're dividing by a. What is our new equation? The new equation would become x squared plus b by ax plus c by a is equal to 0 by a is also 0, so 0. We have not altered the equation. We have just made this for our convenience so that we can compare this x squared term to the p squared term there and say that x is equal to p, right? And now this can be compared to the 2pq term because we have the p here, x is p, isn't it? So this can be compared to 2pq term, and hence find what is q. Why should you find q? So as to complete the square. Only when you find q, the square will be completed. So what is q? You have b by ax is equal to 2pq, but we know that p and x are the same, so we need not mention that. So find q from here. Q is equal to b by 2a. So now complete the square by using this q. You already have an x squared term, mention it, plus b by ax plus q squared. Let me write this in red. Q squared is nothing but b by 2a the whole square. But you cannot just add something to the equation and let it be. It alters the value of the equation, right? So you will have to subtract the same amount. Subtract the same amount to the same equation. Now you have added and subtracted the same quantity, so it's 0 now, so it's null. It's like you haven't done anything, but at the same time you have achieved something. What have you achieved? You have 3 terms which can be used for completing the square, isn't it? But after everything, don't forget this c by a, because it was there from the beginning. Don't forget that c by a. So plus c by a is equal to 0. Right? Now these 3 terms are in this form. So it becomes x plus b by 2a the whole square. We have completed the square is equal to, let us shift the constants to the right hand side of the equation. So this is, our main purpose is what? To isolate x, isn't it? Shift the constants. It's a negative, so this side it becomes positive, b by 2a the whole square minus c by a, right? And a little bit of cleaning up can be done to the right hand side of the equation. B by 2a is nothing by b squared by 4a squared minus c by a. Now you can add or subtract only if the denominators are equal. So multiply both the numerator and denominator by 4a. We get as a result b squared minus 4ac by 4a squared, and your left hand side is the same, x plus b by 2a the whole square. Now sorry, it is the whole square, it is not this squared, I have made a mistake. It is x plus b by 2a the whole square. Now the aim is to isolate x. So take square roots of both sides. What do you get? Your left hand side becomes x plus b by 2a. The right hand side becomes square roots can be both positive and negative. So root of b squared minus 4ac. Now what is the square root of 4a squared? Square root of 4a squared can be written as 2a, isn't it? So by 2a. Now shifting b by 2a to the right hand side of the equation. So the purpose once again is to isolate x and find the roots. So x is equal to minus b by 2a plus or minus root of b squared minus 4ac by 2a, or putting both together as the denominators are the same, you can write it as minus b plus or minus root of b squared minus 4ac, the whole thing divided by 2a. So now the two roots of the equation, if you want to write it separately, are x is equal to minus b plus the whole thing, square root of b squared minus 4ac by 2a, or x is equal to minus b minus the square root of b squared minus 4ac by 2a. Now don't be in awe because it's very difficult, the terms look difficult. It's very easy and you don't have to memorize it. You have so many techniques to derive it if you want it, and once you derive it, it's going to stand in you as a memory, and you're going to use it again and again, so you're not going to forget it at all. I hope you understood how it came about. We did all of this using completing the square method, and we have derived the quadratic formula. Quadratic formula, very famous quadratic formula, just like we do any other problem we have done. I hope you understood. Thank you.